Welcome to another video by Adeptis Academy. Today we're learning something a little different. Deep beneath our feet, hidden from view, lies a world of immense power. Earth holds a powerful secret, a source of energy that's both ancient and incredibly promising for our future. That secret is geothermal energy. The word geothermal simply means earth heat. It's a combination of two familiar words that perfectly describe its origin. Geo for earth, thermal for heat. It's a straightforward name for a naturally occurring phenomenon. This is the natural heat stored inside our planet, a vast reservoir of energy constantly being replenished. And people have used it for thousands of years, recognizing its potential long before modern technology. From bathing in hot springs, enjoying the warmth that bubbles up from the earth, to cooking, harnessing the heat for culinary purposes. Today, we use modern technology, advanced engineering, and innovative techniques to turn this underground heat into electricity for our homes and cities, powering our lives in a sustainable way. Imagine Earth as a giant layered truffle, a complex structure with distinct layers. The core is as hot as the sun's surface, an incredible source of intense heat radiating outwards, constantly warming the rock and water above it, creating a natural heating system beneath our feet. This creates underground reservoirs of hot water and steam, nature's own storage tanks of thermal energy. Like natural boilers, these reservoirs are ready to be tapped for their valuable energy. Geothermal energy taps into these pockets of heat, accessing the Earth's internal furnace, bringing power to the surface, transforming it into a usable form for our modern needs. It's a renewable energy source, a sustainable alternative to traditional fossil fuels, meaning it won't run out anytime soon, ensuring a continuous supply of energy for generations to come. Unlike fossil fuels, which contribute to pollution and climate change, geothermal energy is always available, providing a consistent and reliable power supply, regardless of weather conditions, making it a reliable, clean friend for our future, a vital component of a sustainable energy mix. By using this energy, by embracing geothermal technology, we're working with our planet to build a cleaner tomorrow, reducing our carbon footprint and protecting our environment. Geothermal is Earth's gift, a natural resource waiting to be harnessed responsibly. Clean, powerful, and ready for us to use, geothermal energy offers a promising path towards a sustainable future. Geothermal energy taps into the Earth's internal heat. To understand it, we need to understand where that heat originates, revealing the powerful forces beneath our feet. Let's take a quick trip inside the Earth, peeling back the layers to uncover the source of this immense energy. Earth has layers, each with its own unique characteristics and role in the planet's overall energy balance. First, there's the crust, the solid rocky outer layer that we live on. Beneath the crust lies the hot mantle, a semi-molten layer where much of the geothermal activity originates. At the very center, we find the blazing core, a superheated sphere of iron and nickel. The core's heat comes from leftover heat from Earth's formation and the slow decay of radioactive elements. This heat is constantly moving upward, warming the mantle and crust through convection. Inside Earth, this movement, driven by convection currents in the mantle, shifts tectonic plates and causes volcanoes to erupt. This process brings heat closer to the surface, creating areas of intense geothermal activity. In certain places near tectonic plate boundaries, this heat is just a few miles down, making it accessible for geothermal energy production. These geothermal hotspots have magma chambers relatively close to the surface, acting as giant underground furnaces. This heats underground water and rock, creating vast reservoirs of geothermal energy. Natural reservoirs of steam and hot water trapped beneath the Earth's surface, perfect for powering geothermal power plants. These hotspots are where we can most easily tap into Earth's immense energy reserves. So, how do we actually access this underground heat? Engineers drill deep wells into the Earth to reach geothermal reservoirs of hot water or steam. Scientific tools help pinpoint the best spots using seismic data and heat flow measurements. Once drilled, the natural pressure underground pushes hot water or steam up to the surface. In some places, we use enhanced geothermal systems. Water is pumped down one well, heated by hot rock, and brought back up another well as steam. This closed-loop system lets us create geothermal reservoirs even where there's no natural water. The water can be recycled, making the process sustainable. These engineering feats safely bring Earth's heat to the surface. That's how we turn deep underground energy into clean, usable power. Once hot water or steam reaches the surface, The geothermal power plant converts that thermal energy into electricity. At the heart of the plant is the turbine, transforming thermal energy into mechanical energy, then into electricity. Steam spins the turbine, rotating its blades at high speeds. This drives a generator producing electrical power. There are three main types of geothermal plants, each suited to different geological conditions. First, dry steam plants directly use high-pressure steam from underground to spin turbines. Next, flash steam plants bring up high-pressure hot water, which then undergoes a rapid pressure drop, causing it to flash into steam. This steam spins the turbine. The leftover water is often sent back underground to be reheated, replenishing the geothermal reservoir. Finally, binary cycle plants use geothermal water to heat a secondary fluid with a lower boiling point. The resulting vapor spins the turbine. The geothermal water never directly contacts the turbine, remaining in a closed-loop system. Geothermal plants are efficient and clean energy sources. They run continuously, providing a reliable power supply unaffected by weather. The Earth's heat is harnessed and transformed into electricity, powering our world sustainably. Geothermal energy powers millions of lives worldwide, especially in volcanic regions. Iceland is a geothermal superstar. Almost all its heating and much of its electricity come from the Earth's heat. The Blue Lagoon is actually warmed by water from a geothermal plant. The United States is the world's largest geothermal electricity producer, with major sites like the geysers in California. States like Nevada and Utah are also tapping into this resource. In the Philippines and Indonesia, geothermal energy is crucial for stable local power. Kenya's Olkaria field in the Great Rift Valley is transforming the country's energy supply. Geothermal power brings reliable, clean electricity to developing nations and supports economic growth. These global examples show geothermal's real-world impact. It's a clean energy solution that works across continents. How does geothermal stack up against solar, wind, and fossil fuels? Geothermal's biggest advantage: it's always on, providing steady baseload power 24/7, unlike solar and wind, which depend on weather. Solar and wind need batteries to store energy for when the sun isn't shining or the wind isn't blowing. Geothermal keeps the lights on day and night. Compared to fossil fuels, geothermal is much cleaner, almost no carbon emissions. Modern plants can even capture and store underground gases, making them nearly emission-free. The main challenge? Location. Geothermal plants must be built where underground heat is accessible. Fossil fuel plants can be built almost anywhere, but geothermal is limited to hotspots. New technologies like enhanced geothermal systems are expanding where we can use it. That's why developing geothermal where possible is so important. It's a key player in the clean energy team. Geothermal energy has some big advantages. Its surface footprint is tiny. Plants are compact, leaving more land for nature or farming. Most of the action happens deep underground, so the landscape stays beautiful. Geothermal plants are reliable and long-lasting, providing steady power for decades. The fuel, Earth's heat, is free, making electricity prices stable and predictable. These plants create high-quality jobs for local communities. For countries that import oil or gas, geothermal means more energy independence. It's a homegrown resource, boosting security and self-sufficiency. Geothermal is a smart, sustainable way to power our future. It's clean, reliable, and right beneath our feet. Geothermal energy isn't perfect. There are challenges. Finding and drilling wells is expensive and risky. Sometimes the heat or water isn't enough. The best resources are in specific regions, so not every country can use geothermal easily. Enhanced geothermal systems are promising but still costly and new. Environmental concerns include managing underground gases and minerals, but modern plants recycle and contain them. There's a small risk of tiny earthquakes when injecting water underground, so sites are carefully chosen and monitored. Despite these hurdles, careful science and engineering keep geothermal safe and responsible. Overcoming these challenges will unlock even more of Earth's energy. The future depends on smart solutions and innovation. Our world needs clean, reliable energy, and geothermal is a key part of the solution. It's a quiet powerhouse, providing steady electricity to balance solar and wind. Think of geothermal as the dependable teammate, always on the field. Its constant power helps us build a 100% clean energy grid. The Earth holds enough heat to power humanity for thousands of years. The challenge is unlocking this energy safely and affordably. With new technology and investment, geothermal can become a global powerhouse. Every time you see a hot spring, remember the promise beneath your feet. Geothermal is more than hot water. It's a promise of a stable, clean future. By embracing Earth's heat, we're building a brighter tomorrow for everyone.